Here's the solution for day 3. Graph the complex number and find its trigonometric form. 3 minus 3i in standard form would be 3 plus negative 3i. In an earlier chapter, we graphed complex numbers on the complex number plane. So the first number here gives us the real coordinate. This here gives us the imaginary coordinate. You start at the origin, you go over to positive 3 on the real axis, and then go down till you get to negative 3i. This dot represents this complex number. The reason that there's a trigonometric way to write the location of that dot is because of what we've studied in the past about trigonometry. Here's an x and y axis. If you draw the initial side of an angle along the x-axis and then rotate in this direction to create a terminal side to an angle, then this dot at the end of that terminal side can be expressed using trigonometry in terms of this angle of rotation, which we've called theta in the past. The distance from the origin to that dot we have called r, the radius, in the past. So we're going to use these ideas from trigonometry to work with the complex number plane. If our complex number is z equals 3 plus negative 3i, then the related trigonometric form to write the complex number is r times the cosine of theta plus I times the sine of theta. We need to find the value of r, and we need to find the value of theta. We know from our earlier work with trigonometry that r squared is equal to a squared plus b squared. That comes from imprinting a right triangle onto the coordinate plane, calling the distance from here to here a, and the vertical distance b. We can follow that same idea with the complex number plane. In our complex number, the first number is going to be our a, and this coefficient right here will be the value of b. This means that r squared will be equal to 3 squared plus negative 3 squared, which is 18. Therefore, r is the square root of 18. Because 18 is 9 times 2, this is 3 square root of 2 when you simplify. The other thing we need to know is the value of theta. If that dot is down here in quadrant 4, and it's the end point of the terminal side of an angle called theta, then here's where angle theta is located in the picture. An initial side goes out to the right, the terminal side comes down to the dot, and angle theta is this rotation right here. We need to find that value. What we have to work with are values of a and b. Let's use the tangent function. The tangent of theta is equal to b divided by a, which in our problem is negative 3 over 3, which is equal to negative 1. Theta will be the inverse tangent of the negative 1. That is, what angle in quadrant 4 has a tangent value of negative 1? That angle is 7 pi over 4. Now we're ready to write our trigonometric form. The value of r is 3 square root of 2 times the cosine of 7 pi over 4 plus I times the sine of 7 pi over 4.